Welcome to Ask and Learn.
Number 98 in Chapter 5 of Chemistry Central Science. So an automobile fuel, E85, consists of 85% ethanol and 15% gasoline. E85 can be used in so-called flex fuel vehicles, which are FFVs, which can use gasoline, ethanol, or a mix as fuels. Assume that gasoline contains a mixture of different octanes, which are isomers of CH-H18. At the average heat combustion is C8 of C8H18 is 5,400 kilojoules. You see that here. And that gasoline's average density of 0.70 grams per milliliter, and density of ethanol has 0.79 grams per milliliter. By using the information given as well data in Appendix C, compare the energy produced by combustion of 1 liter of gasoline and 1 liter of ethanol. So we have the heat of combustion for gasoline, we got to find that for ethanol. So we're going to use Hess's law, delta H of reaction is equal to delta H of product minus delta H of reactants. So first we have to balance those equations. So we have 2 carbons here, we had a 2 here, we have 2 waters here, we have 6 over here, so we have to have 3 times 2 is 6. Now we have 1, 2, 3, 4, us 4, or 1, 2, 3, 7 oxygens on this side. We have 3 on this side. We're gonna assume that 1 mole of ethanol. So now we have to find. So that's one oxygen here. Now we're gonna put 3 in front of here, so that creates 6 more, so that you have 7 on each side. Now we're gonna put into Hess's law. So delta H equal to 3 times negative 285.83 plus 2 times negative 393.5 minus negative 277.77, and the delta H for oxygen is 0 because that's an element at standard state. And we're going to solve this. So delta H, delta H is going to be minus 1367 kilojoules per mole. So the heat for ethanol, we're going to put that as a positive 1367 kilojoules per mole, because this is the amount of heat that's being released. Now, by assuming this, so now we can figure out how much energy you're producing from each one. So we know that we're doing 1 liter for each. Now, we know the density that we have, 0.79 for ethanol and 0.70 for gasoline. So first, we're going to know 1 liter is equal to 1,000 milliliters. Now, we have by 0.70 times 1,000 is equal to 700 grams of our gasoline. Then you got 0.79 1000 is equal to 790 grams. So now we have to find them. Now we convert grams to moles, so we're going to find the molecular weight. So it's C of our gas, which is going to be CH18. So there are 8 carbons here. That's 8 times 12, which is 64, plus 18, which is going to be 114. For ethanol, we're going to it's going to be 2 carbons, that's 24, plus 5 hydrogens, and plus an OH. That's going to be 46 grams per mole. So this is going to be our gasoline. So 700 over 114 is going to be 6.14 moles. Now for this one, 790 over 46 equals 17.17 moles. Now we're going to multiply this by the heat of formation, the heat of combustion, to be able to get the amount of energy we have. So 6.14 times 5,400 which is going to be 33,156 kilojoules. Now we're going to multiply 17.17 times 1,367. Which is going to be 23,471 kilojoules. So that means that gasoline produces 1 liter of gasoline produces more more energy than 1 liter of ethanol. This is one of the reasons we use gasoline-powered cars as opposed to ethanol-powered cars. Even though ethanol is a usable fuel source. Okay. Next, for part B, assume the density and heat combustion of E85 can be obtained by using 85% of the values for ethanol, 15% of the values for gasoline. How much energy would be released by the combustion of 1 liter of E85? So this is actually pretty straightforward. So if we have 0.85% of our ethanol, then we're only going to be producing 85% of this energy value. Conversely, if we have 15% of gasoline, we're only going to we're only going to be producing 15% of this energy value. So you can write it simply as this. We're going to add them together because we have a mixture of these things, so you have to add the energy. So they're each going to burn and produce their own specific both specific amount of energy, but we have to find the energy release for the mixture itself. Six. So the amount of energy released from E85 is going to be 24,924 kilojoules. Now we're going to move on to part C. So how many gallons of E85 need to be produce the same energy as 10 gallons of gasoline? So you can do this pretty straightforward. So we know that the value for E85 is 24,924 kilojoules. And for gasoline, it's 33,156 kilojoules. So we need to find what the ratio is, like how much more energy are we producing, and proportionally how much more energy we're producing of gasoline per E85. So we do this 33,156 over 24,924. That gives us 924 1.33. So you would need 1.33 gallons of E85 to produce the same amount of energy as gasoline. But since we're not using 1 gallon of gasoline, we're dealing with 10. So 10, we're going to multiply it. So 10 gallons and 10 gallons of gasoline times 1.3 gallons and of E85 per gallon of gasoline. So that means we would need E5. So that means that we would need 13.3 gallons of E85 to produce the same amount of energy as 10 gallons of gasoline. Now, for part 4. Part D. Gasoline costs $3.88 per gallon. And what is the break? They want to know what the break-even price per gallon of E85 if the same amount of energy is to be delivered. 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 So basically, what they want to know is what's the price if we want to produce the same amount of energy with E85 as we do with gasoline. What is going to be the price per gallon? Yeah. So we can think about it this way. Similarly to how we had the ratio of energy output per gallon, that's going to be equal to the ratio of the price per gallon, because our prices are fixed to our energy. X. Now we know this is one. We know that 1.33 is equal to what's on the left, so 3.88 over x. Now, then we're going to do x is equal to 3.88 over 1.33, and we get our answer. Answer that our gas is for ethanol is going to cost us. Our gas is going to be costing us $2.92. Cents per gallon. Gallon. Because similarly, we have to do a certain amount of pricing per energy. So if we have a similar ratio for for energy, we also have that same ratio for pricing. The specific volume we're using is irrelevant because they have the same volume and they're going to cancel out. So that's how you do this kind of problem.